So I'm mostly working with subjects, as I mentioned, control, optimization. As I tend to call myself, I'm an algorithm builder. That means I have this positive attitude towards society, toward life, that I will be, and my group and my university and my colleagues will be able to produce algorithms which can help society of removing some dangerous jobs, removing some boring jobs. And what is this optimization? What is this control? Well, it is gathering a lot of data, trying to see some pattern in this data. This pattern, it means model. A model predicts the future. As soon as we have future, we can take decision. That means if the model moves in our objects move, whether it's car, whether it's airplane moves in the wrong direction, we have a chance to predict this motion and then correct it. But here is a catch. In order to do this, we use a huge amount of data. And this data might be from time to time revealing private information. So here is the subject of our project, which is how on earth would we do our optimization, our artificial intelligence, our machine learning, such that we do not reveal any form of private information. And I strongly believe that it's possible.
My name is Astrid Oberborbeck Andersen, and I'm a social anthropologist. One of the questions that we work with in this kind of project is, how does big data, datafication and digitization change society and human relations? And what does it mean that we now live in a world populated not only by humans, but also by a variety of technologies and algorithms? How do we as individuals become acquainted with algorithmic life, and how does it impact our everyday life?
My name is Mads Christensen. I'm a professor in signal processing at Oberborbeck University. And in this project, I conduct research on how to process signals, that could be video, audio, speech, what have you, in a way where the user's data is protected.
And I'm Adrienne Mannov, and I was a postdoc in the project, and I'm an anthropologist. And my role in the project was to try and understand what kinds of perceptions of security there were among users, among different potential case studies, but also among our co-researchers. So trying to understand what kinds of notions of security and privacy were embedded in the math and in the engineering.
I was discussing with some colleagues that in a number of engineering fields, we face the problems with security and privacy, and quite clearly this would require interdisciplinary research. And we thought that having anthropologists in the project would help us understand what privacy means. So in reality, what the mathematical problems we would try to solve, what they should look like. The second issue is where a lot of these organizations and companies are at the moment. Because obviously there are companies that collect a lot of data and make use of that data for various purposes. But for a lot of companies also, they are just starting to move into all this AI, machine learning world, and they have started collecting the data. But a lot of them, I don't think, they don't really know what to do with all this data yet. And in a lot of contexts, when people have talked about security and privacy, what they really meant is like classical cryptography, that I send your data from here to here using encryption, so nobody can listen in on. That's not the issue.
Right.
The issue is that your data will end up somewhere and be sold off to third parties for who knows what. Is it actually necessary to collect all the data to solve the problem?
Right.
And what we found is that no, that's not necessary. Right. You can actually protect the data and solve the problem without sharing the raw data there. This, of course, goes completely against what some of these big tech companies make their living on.
We were asking anthropological questions of the mathematical theory. And as time went by, it became clear that there was this odd discrepancy. So we understood that there was something called the ideal world in the cryptography. And then there was something called the real world, which was always compared to the ideal world as a standard. But when we started looking at what this real world was, we realized that it wasn't what we would call the actual world. So what are people actually doing in the world? How are they actually communicating with each other? There was this discrepancy between how the theory worked and what was actually happening.
Yeah.
And that was a real discovery in your group as
Yeah.
well. So one of the things that we worked with this idea of the socio-mathematical, what the social interaction is in the network, but also understanding what some of the more social ideas were behind the logics that some of the terms that popped up quite often were things like intuition, often references to beauty, a real sort of aesthetic appreciation of something, of a protocol or a system that worked, and it was beautiful and it was simple and it was, and those are really sort of social sentiments, so how does that then feed into how you build the work that you're doing?
My name is Jarons Gundersen, and I've been studying math at Aalborg University during the last couple of years, especially focused on a branch of cryptography known as secure multi-party computation.
So hi, I am Chongqiu Li, and I am a PhD student in Oberborbeck University. I'm working in secure project, and my job is actually to optimize general distributed signal processing for privacy preservation.
In general, in math, I like that we prove things. When you have a result, it's known and something. It's very common nowadays that we have something on our computers and online, and we want to keep it secret. So I think cryptography is a very hot topic, you could say, and very relevant for real applications. We have these more or less three types of worlds, you could say. We have what you could call the actual world, where we have all the parties, but maybe not all these communication channels are available. So it could look something like this. Then we have what we typically compare with in MPC, what we call the real world in MPC, where we have all the parties and all communication channels available. And then we have the ideal world, where we have all the parties, and then some trusted third party up here. So they just send all the inputs to him, and he sent the output back. So in each situation, we want to compute some function here, where each party has one of these inputs here. But the problem is that even though we can show that a protocol is, in this situation, is as secure as in this, then it might not actually be as secure as we have when we have this actual world here. So that's the reason why we need to maybe come up with a new way of defining what is security, because we might not be able to achieve this situation when we have a situation like this.
I cannot achieve the ideal world defined by mathematicians. And we found that, okay, the problem is coming from the topology assumption. So what they are doing is they always assume full connected graph. But what I am encountering is not fully connected.
We have to kind of redefine what ideal is depending on the graph topology, actually. But I think it will take many years to convince mathematicians that this is the right way of doing it. If this is the actual world, that we do not have this fully connectivity, then I think the theory should be made such that it fits the actual world.
I think certainly the problem we are working on will at least make it easier to reach the user case, because in a real user case we will see the actual world, not the real world. What we are doing is we are pushing this further to make it more adaptable to the real applications.
To give you an idea about the discrepancy between sort of what may happen in the real world and what the theory tells us, well, what happens if this one here wants to perform and participate in this network and be part of this computation, but this node here is corrupt? Then there's no way for this node to communicate with the other ones without using this corrupt node here.
Make a big C here for the corrupt one. When I think about this as an anthropological field, I imagine this is actually a representation of some people in different homes that have sensors and they want to calculate something together. Then the information that is in each of these little places is someone's home, is someone's intimate space. This is what I meant before about the socio-mathematical, right? Because that's the connection between this graph where we can say something about it mathematically and what's secure and what's not secure, but we can also look at it as a representation of a social reality.
Absolutely.
Right.
Absolutely. And you have to, because otherwise you don't understand what is the nature of the information that you want to protect.
Right.
And what does it even mean to protect it?
What we have is an iterative process.
MPC.
Secret multi-party computation.
A private information is a secret.
The project is about enabling computation on data.
We speculate on how to re-engineer the world.
Fully connected network.
You don't need to give your data to get what you want.
Can we trust the network? We didn't talk about trust in front of the camera.
Data security is a social and political project, and not just a mathematical or technical one.
Real numbers.
It is important to find methods to represent real numbers.
Natural numbers.
I believe in logics.
A tree could be a person.
I believe in logics.
We live in a world populated by algorithms and data.
We assume a fully connected network.
These networks are dynamic in nature.
In order for our use to be helpful to society, we have to accept the actual.
Mathematics are concerned with what you can say with great certainty.
The claim that AI is somewhat connected to what the brain does is a fantasy.
I don't think AI exists.
Computers can't deal with real numbers anyway.
Computation is developed for idealized situations.
We need a new ideal to prove our protocols.
A temporality that is not yet.
What does it mean to integrate algorithms into the world as a social place?
We are trying to be optimistic.
Data is the new oil.
A new ideal.
On the edge of being naive. Algorithm crash numbers and deliver signals.
Algorithms are machines.
Networks.
Quantum theory.
Energy.
Fantasy.
Fantasy.
The problem.
Trust.
A trusted third party is not always as trustworthy as we would like.
The tools do not match the kind of problems we're trying to solve.
We do not know where the hammer will hit the nail. Algorithms will make the world a better place.
What kind of hammer is produced by anthropology?
A new best possible world